objective for this lesson is to describe and identify precipitation reactions. Now, before we can obviously look at precipitation reactions, we have to understand what a precipitate is. So, very simplistically, it's a visible solid product of a chemical reaction that doesn't dissolve. So, we're going to look at an example to clarify this definition. So what we're going to have here is we're going to have copper sulfate and barium nitrate. Now, if we look at our tables of solubility, we can see that copper sulfate is soluble. Cool, so we know that one's going to dissolve. Barium nitrate, because it's a nitrate, it is also going to dissolve. So we're going to throw those guys into the water, and that is going to dissolve into its ions. Very nice. Now, what's going to happen is those ions are going to be floating around, they're going to be moving around, they've got a little bit of energy, so they're just going to be moving around, and as they do so, they're going to be bumping into each other. And they're obviously going to be ionically attracted to each other, and so in this case you've got a copper nitrate bumped into each other, and copper nitrate is soluble, right? So it's still going to dissolve. So it's going to just break into its ions again and move around. However, at some point here that you can see we've got a barium and a sulfate coming together. Gives us barium sulfate. So if we look at our chart again, we can see that with that exception, we've got barium sulfate being insoluble. So what happens is now that barium sulfate becomes a solid because it doesn't dissolve, and it drops to the bottom there. And those ions are going to keep moving around and bumping into each other, dissolving, or if it's a barium and a sulfate that come together, they're going to form an insoluble solid, which we call a precipitate. And there is our precipitate formed right there. So our copper sulfate, we write as CuSO4, which is obviously aqueous, plus the barium nitrate, which is aqueous. We have a copper nitrate, which we know is aqueous because it was soluble, and the barium sulfate is a solid, so we give it that little S there. So, precipitation reactions. Let's just summarize this now. So, when we have solutions of different ionic compounds and they're mixed, the ions will move about and they're going to bump into each other. If the two ions form a compound that is soluble, quickly dissolves and returns the two ions floating about the solution. If two ions form a compound that is insoluble, it'll form a precipitate in the solution. So we're going to use the example now of silver nitrate plus sodium chloride. It will form sodium chloride and sodium nitrate, where the first two are obviously soluble and our silver chloride is the insoluble one. So that leaves our sodium nitrate being soluble. And we would then write that out using the correct nomenclature. What we're going to do now is mix the following solutions and see if precipitates will form. Lead nitrate and sodium hydroxide, both two clear solutions. And we can see that's very evidently created a light milky precipitate. Okay, now we've got lead nitrate and sodium chloride. Nada. Worth noting, no precipitate. Okay, we've got our lead nitrate. Oh, Baba, stop touching. You just want to move it there, do you? Yeah, for safety. Okay. Lead nitrate and potassium iodide. And we have a very obvious yellow precipitate here. Okay, we've got silver nitrate and the sodium chloride, and a very strong white cloudy precipitate formed there. Now, generally speaking, when we'd be doing this in the lab, we wouldn't be using such large quantities. I'm just doing the large quantities purely for demonstration purposes. We would be normally using a little spotting tile and using very small amounts. Otherwise, we'd just be using so many of these solutions. Okay, for our final reaction, we're going to mix copper sulfate and sodium hydroxide. It is, it's blue. Yeah, it went a little bit cloudy blue. I can see it's almost turned gelatinous in there. I don't know if you can see that, but it is quite thick. You might even be able to observe it when we pour it into the waste container. Oh, not so much, but it's definitely it definitely thickened up, which I could see just by moving around the cloudiness. So what we saw was the lead nitrate and sodium hydroxide formed a white precipitate. The lead nitrate and sodium chloride formed no precipitate. The lead nitrate and potassium iodide formed that bright yellow precipitate. Silver nitrate and sodium chloride formed a white cloudy precipitate, and copper sulfate and sodium hydroxide formed that blue precipitate. Now it's worth noticing this no precipitate that formed with the lead nitrate and the sodium chloride. If we look at our solubility table, we'll notice that obviously lead nitrate and sodium chloride are both soluble, and sodium nitrate would obviously be soluble because it's a nitrate. But lead chloride, based on that table of solubility, should form a precipitate, but it didn't. And there's a couple of reasons, and the most common reasons are that our solutions didn't have a high enough concentration of ions, or another factor can be the temperature, and it has been quite hot lately, so that could have been a factor in not forming the precipitate. Under the right conditions, it should have formed a precipitate. And you can check on that table to check that all those other ones did correctly form precipitates, and you could even determine which compound formed that precipitate.